Have you ever wondered how programming languages evolved over time? Our journey begins in the realm of the first-generation languages, the machine-level languages. These were the pioneers, the trailblazers, written in nothing more than the binary language of ones and zeros. These languages communicated directly with the machine, making them incredibly efficient. But they came with their own set of challenges. They were complex, hard to debug, and not particularly user-friendly. As we move forward, we encounter the second-generation languages, the assembly languages. A step closer to human language, these were slightly more readable. They used abbreviations for operations and allowed programmers to use names instead of numbers for memory locations. This was a significant improvement, making programming a bit more accessible and less error-prone. But the evolution didn't stop there. Something big was on the horizon, a change that would redefine programming forever. And then a significant leap happened with the advent of third-generation languages. With third-generation languages, programming began to look a bit more like the code we're familiar with today. These languages introduced a seismic shift in the way we program. They were characterized by a syntax closer to human language, making coding more accessible to a broader audience. One of the notable third-generation languages was Fortran, a language designed for scientific and engineering computations. It brought efficiency and speed to complex mathematical computations. Then came COBOL, which revolutionized business data processing. It was designed to be easily read, making it a favorite in corporate environments. And we can't forget C, the Swiss Army knife of programming. It's a general-purpose language that struck a balance between high-level readability and low-level control over the computer's hardware. These languages made programming more efficient, more accessible, and opened the door to countless new possibilities. But the evolution didn't stop there. Languages continued to evolve, becoming even more user-friendly and powerful. As programming languages evolved, a new paradigm emerged: object-oriented programming. This shift was nothing short of revolutionary. It introduced a new way of thinking about code, by breaking down software into objects, each encapsulating its own data and behavior. This allowed for more efficient, organized, and modular programming. In the mid-80s, a language named C++ took the programming world by storm. It was one of the first to combine the efficiency and flexibility of C with the concepts of object-oriented programming. Java, introduced in the mid-90s, further popularized this paradigm with its write once, run anywhere philosophy. And then came Python, a language celebrated for its simplicity and elegance, making object-oriented programming more accessible than ever. These languages opened the door to more complex and robust software systems, transforming the way we design and interact with technology. Today, object-oriented languages dominate the programming landscape, but the evolution of programming languages is far from over. As we look to the future, programming languages continue to evolve and adapt to our changing needs. The next chapter in this story is being written by the emergence of new paradigms and languages, such as functional programming and languages like Swift and Rust. Functional programming, with its emphasis on pure functions and immutable data, is gaining traction as a powerful tool for managing complexity in large code bases. It's a paradigm that treats computation as the evaluation of mathematical functions, reducing bugs and making code more predictable. Then we have languages like Swift and Rust, designed with modern challenges in mind. Swift, Apple's brainchild, boasts a friendly syntax and is aimed at making coding more accessible. Rust, on the other hand, is focused on performance and safety, particularly around concurrency, a major challenge in today's multi-core world. The evolution of programming languages is a testament to our continual quest for better tools to solve our problems. So we've journeyed from binary to high-level, object-oriented languages and beyond. We've seen how programming languages have evolved from simple sets of instructions to complex systems designed to solve intricate problems. In the early days, binary code was the only game in town. But as our ambitions grew, so did the complexity of our tools. High-level languages like Fortran and COBOL paved the way for a new era of software development, making it easier for programmers to write and understand code. Then came the rise of object-oriented programming. Languages like Java and Python revolutionized the way we approach software development, allowing us to model real-world problems more clearly and efficiently. And let's not forget the future. With the rise of technologies like machine learning and quantum computing, we're sure to see even more exciting developments in the world of programming languages. Who knows what the future holds for programming languages, but one thing's for sure, they'll continue to evolve as long as we have problems to solve.